The final piece of the puzzle, we're going to have a panel where you guys can throw questions at all the speakers that we've had. After that, we have some food outside as well, so please do stick around where we can have some drinks and chats and follow up with anything you don't want to ask in person. But please do throw questions at these guys. They're really keen to share what they're doing with you guys. And thank you very much for sticking around.
Everyone thought.
And we have mics, so we're going to bring round. So please wait till we throw them to you so we can hear you.
Okay. Yeah, I see a question just here. Should we ask for affiliation and name? Yeah, you should just mention who you are, please, and far away, either to one of us or all of us. Or...
Yes, Rick Parker, fellow of this academy and visiting professor at Imperial College. I think primarily to Stephen, but I'd value the views of the rest of the panel and the chairman. I didn't see among your various models the UK's Energy Technology Institute ESME model. This, when we ran it, showed that the optimum for the UK, both in terms of environmental impact and overall economics, was a mix, a third nuclear, a third renewables, and a third gas with CCS. So given that third renewables, nobody's talked much about nuclear tonight. You had the high nuclear scenario in your bit, which is probably quite similar to the ESME output. And the chairman was a little disparaging about nuclear in his introduction. But one of the big opportunities, if we're going to get to 33% nuclear, we're currently 17%, most of that 17% will be beyond its design life in the next 7 years. And we won't have built the first new one within 7 years. So we're going to do something different. And that, I believe, is small modular reactors. Now, 2 years ago, the government put up 250 million for work on small modular reactors, and they've so far failed to spend any of that. I wonder how you see SMRs fitting into this view, and if any of the panel agree or disagree that nuclear is part of the future, I'd be interested to hear that as well.
Okay.
Go on, Steve.
You want to go for that straight away? Okay, so the last time I went to it was the NEC in Birmingham, like a massive thing, and I went to a presentation on small modular reactors, and it got very excited about it, and I thought, yes, this is obviously quite a revolutionary technology. And then similarly, government puts up the money for it, struggles to spend it. Okay, and in terms of the modelling, in terms of all the value pools that I've put up and things like that, the actual size of the reactors doesn't really matter too much into the way that the value pool is constructed and how you can get at it. It's more about the cost of the technology and whether or not it's an avoided cost to actually invest in that technology. Nobody's got any idea about how much it would actually cost to put a small modular reactor where it would need to be. So we've just completely been unable to put that into the value pool model. What we are doing is, rather than just talking about results, we're trying to publish the model and make it open access. So people who run ESME, people who run these things, can just put another scenario in it and see what it does to the value pools, which I think is probably the way forward, because as much as I've enjoyed this process, I probably don't want to be doing model run after model run after model run. But I would love to see somebody put SMR in there. When we looked at whether or not we could do it, the cost ranges were just so wide. I thought, I don't know how to put that into an Excel spreadsheet. So
I can put you in touch with some previous colleagues who have done some estimates.
That would be really good. Thank you.
If I could just have a follow-on, the critical thing, any electricity generator?
That's a good point. I feel I would be pushing the boundaries of my expertise to answer any further.
We'll talk later, thank you.
So I should probably just chip in regarding my introduction, as it covered nuclear. I mean, I think the key question for us all is, in my characterisation, that Plan A world of, decarbonised electricity and then use that across the whole of the energy sector. £92 for however many years it is indexed. Will we find ultimately that that would have been a good number? We just don't know. SMRs seem to be the flavour of the month in terms of all the talk around the energy system. I've yet to see sort of decent numbers for it, and that doesn't mean they don't exist, but there's an awful lot of chat about it at the moment. I have a perhaps naive hope that it will turn out that the pause that has sort of come, because it is really a pause in terms of deployment of CCS, nuclear, large offshore wind, we'll look back and realise that the dramatic shifts in the costs of photovoltaic and storage in particular will mean that those pauses actually saved customers money. It's not that we won't need any of those big sources, it's just that technology innovation will have overtaken those and frankly, looking at the politics, I think, you know, real breakthroughs in the economics of some of this stuff, such that customers start to pull rather than politicians have to push, is our sort of best hope at hitting the targets these days. I'll probably take some other questions rather than just, I'm sure the panelists all have a view on that question, but I wanted to get to their particular technological offerings. Have people got comments that would address some of the other presentations?
You said not to be scared, Chair, to ask from the panel if you do.
Oh, sorry, yeah, let's take this one here. Thank you.
Hello, my name is Brian Miller. I'm the managing director of a non-energy company. But I remember just a few years ago, fusion was being hailed as a possible disruptor to the energy of the future. And I believe there's been billions sunk into trials and a lot of advancement there. But that doesn't seem to feed into anything anyone's thinking about here. I'm just wondering what happened to fusion.
It's 40 years away, right? It's always 40 years away.
I always have it down as 30 years away. I'm obviously a bit more ambitious than you are, but yeah, I mean, yeah, but the trouble is another, you know, I mean, a person less generous than I would say, but next year it'll still be 30 years away, which doesn't get you to 2050. So fusion hasn't, I mean, obviously the amount of energy in the molecule is just enormous, and if you can start to unlock some of that stuff, there's some great stats lying around on this stuff. But it has by and large drifted forwards 1 year per year, and that's why it doesn't sort of feature.
Yeah, and I think just to reflect on it, there's plenty of stuff that we've got that we can do it with now, and even if somebody was to really crack fusion tomorrow, the amount of effort that would have to go in for it to contribute as much as we know we can just do with like established safe technologies like offshore wind, like grid connected solar, like our new storage technologies, it kind of becomes a bit of a white elephant. So, but I get where you're coming from, but it's just in the system.
Melissa, go ahead.
I think one of the things to keep in mind is no technology stands still, right? So it's always competing with the other technologies I was saying before. So people forget that, you know, coal hasn't stood still either, right? And it's all to the benefit of everything, with every technology or every horse running its best race. And I think that's sometimes when we compare technologies, that's what we get wrong, is like you kind of say, my technology is going to improve and everything else is going to stay the same. And actually that's not true. That was one of the things when we were doing the technology study for Secretary Chu, was try to figure out where would everybody be at 2020 or 2025 or whatever, because everything is going to move. And then that's the challenge with fusion and some of the others, is they've got to not only crack it in the lab, they've got to actually catch up where people are already on a commercialization or scale-up path.
Good, I see. Excellent. A veritable forest of hands now, suddenly. Here we go. We'll start this side, and then there were three over there.
Thanks very much. Elizabeth, I really enjoyed your point about how the infrastructure, we need to think about linking the internet and electricity together and think of these as intrinsically linked. And I was wondering if maybe you and Stephen could have a bit of a riff on that, based on the how consumers can, how how consumers see their energy usage, the peer-to-peer trading, they're seeing it as a game between sources. I'd like to hear more about that and what the whole panel thinks.
Yeah, thank you. So I suppose in the scenario where we're in right now, in the sort of Ugandan context, it's a setting where consumers have had quite a lot of control over their energy source, and they've had to take control over their energy sources because they can't rely on the grid. And so it's a setting where perhaps they would be more proactive and more willing to engage in that sort of a setup. So in our setup, for example, you have already people who have, so I would actually see it as, perhaps, there are questions about, grid defection, what's going to happen when storage gets to that point where it's super reliable. And when, sort of solar, can we get to a point where, that sort of shift can start happening. But if you look in the African context, people already have their independent energy sources now. And so it makes for a really interesting case study for what things could look like in a number of years. And so that's how we see it.
The only thing that I would say to that is I would love it if a Ugandan startup came and showed our big energy companies how to do it, because they've all said peer-to-peer is not going to work, peer-to-peer is too difficult, it doesn't fit with the existing market setup, and I would absolutely love it if somebody could come and say, we can do it for small-scale companies and households in Uganda, and we can absolutely do it here.
And then actually, so our approach to that is saying actually, on the grid, for example, because even within the grid space, 50% of customers have reliable electricity. So what we can add is that second level, as you actually mentioned in your presentation, this optimization of flexibility. And having that second layer of local optimization really allows, so if you think of sort of the grid operators running with two layers, one where they just, the sort of traditional centralized arrangement, and then a second layer which really allows them to make use of these independent sources and then control where local demand meets local supply. And so electricity is not having to travel longer distances, so you're reducing the sort of losses that you would have otherwise within your system, becoming more efficient, and being able to address this issue of affordability, and affordability in two ways also. In the other way, saying, okay, if I have my diesel generator, 4 rooms in my house, it's not sort of a graded on-off system where if, say, the other 3 people are not in, only one person in, so depending on load factor also, the cost of diesel can change from maybe 50 cents per kilowatt hour, again, I'm talking in the Ugandan context, up to $1.20 per kilowatt hour. So by being able to add on and manage the load, you can actually end up with a far more affordable, more cost-effective system.
Okay, thank you for that. And I would just comment on that. It's interesting to hear you sort of characterize it in the trilemma, that it touches all 3 elements of the trilemma. And we in our economy here, I guess we're always trying to hold security of supply steady, press on the environmental side, and worry about the other end of it. So that's a great benefit in terms of starting with a less developed system. Yes, there are a number of questions over this side. I see two females just here. Can we take those 2?
Thanks. Lizzie from E4Tech. Angelo, I was wondering if you could talk a bit more about what your system would look like at a sort of the scale you would imagine it might be commercial at. So you indicated it might be maybe megawatt, tens of megawatt scale. What kind of size of ring are we talking about practically? Does that come with issues? And I assume it would be underground by the look of your diagrams. Do you need kind of particular rock or particular circumstances? And how does that compare then to the requirements that you have around other big storage technologies like pumped hydro? Because that's one of the challenges of pumped hydro, that you have very big scale infrastructure, very specific requirements for the geography of the place that you're putting it.
Thank you very much for the question. The answers are quite easy from my point of view. The point is that the big advantage that we see in the technology is exactly the fact that there will be no particular constraints. It's absolutely deployable wherever you want. The sites, the minimum size, of course, based on the fact that it's a technology that is using the geometry. So bigger is the ring, lower will be the cost because more efficient will be in terms of accumulation of the energy. So the minimum size that we are planning to deploy at commercial level would be 10 megawatt. That means a ring diameter of 20 meters and let's say a size of the diameter that could be in a range of half meter or 1 meter. And instead the real target size for us would be the 100 megawatt device with a diameter of 100 megawatt and a size of the ring of 1.5 to 2 meters. So in this way, we have made some third-party validation about the target cost. We should be able to provide on the market a solution that would be less than, let's say, lower than 50% of the current cost. So in terms of LCOE, we will be in the same range of the hydropower costs. That means that currently this will be the only technology able to provide the storage solution for renewable energies. The target would be to use for renewable energies because, of course, the major issue that you have if you're running a PV plant or you have invested in a windmill is that you produce electricity that not always is accepted by the grid and you're losing money. So if you have an economic solution in order to store electricity and then to deploy later on into the grid will permit you to recover money and so to, in terms of investment, make the investment into the renewables easier and to permit to the grid to accept the renewables as a reliable source that is not just driven by the weather conditions. And in terms of constraints, there are no particular constraints, and what we see is that also solutions for grid applications or even for industrial application, in a moment in which there is a big factory producing paper or producing steel, you need to have a quite effective backup solution. This could be a backup solution too. So it's quite wide range of application that we see.
So I'll just clarify one stat, which because I asked the same thing earlier. So that stat was 100 meter diameter.
Yeah.
1 meter thickness.
Yes. And can
100
be
megawatts. So that's an interesting stat. We're talking about 100 meter diameter. This is a big piece.
But the good thing is that at the end is not so, I say 100 meters, but it's a ring. It's quite thin to be a so big ring, and you can put under the ground. So you don't even see. You just need to have the conversion part that is on field, but the rest can be buried, so no visual impact.
Great, thank you. And I was going to go to that lady behind.
Thanks. I'm Rachel. I'm independent with a number of startups who are innovative in the energy sector, and I've got two very quick questions. One is for you, Stephen. When you were talking about the increased value proposition for some of these other scenarios, I'm assuming that's not inversely proportional to the increased cost to customers. And so it'd be interesting, what is it that actually creates the extra value without just increasing cost to customers? And Elizabeth, that's really, really awesome what you're doing. And I was just interested, what are the things that for you have kind of enabled, what are the big things that you felt have been really important in getting you to where you are? And what are the big things that in the future you think will be important in actually the success? Thank you.
Okay, yeah. So some of the new revenues are just basic new revenues, like two utilities putting energy into a vehicle is just a new revenue, and obviously that's quite a simple one. In terms of the flexibility, optimization, that's their values that are going to be necessary to balance a lot of the intermittency anyway. So they might increase cost to consumers, but it's in order to allow the system to work. In terms of the, I'm just trying to think of a good example in the, so in the distributed electricity, in the local low carbon stuff, the cost comes to whoever it is that doesn't capture that value pool. So it's not so much about it's extra money, it's a reallocation of capital within the sector. So it just doesn't come from a different part of the sector. So it might be a gas plant that's losing out. One of the biggest drivers of cost in the sector across the scenarios is final demand and how much the plants get utilised as well. So in some of them we see the plants being utilised, the thermal plant being utilised not very much at all, which then leads to massively peaky prices, which would then, if we were sophisticated enough to feed that back into our flexibility, would increase the value of the flexibility resource as well. So it's more of a reallocation within the sector rather than an extra cost to consumers.
Okay, great. Elizabeth, do you want to?
Yeah. So, so the question was, what enabled us to get to the point where we are, and what do we need to get to our goal? So I would actually say it starts with a change in legislation. So in 1999, there was an unbundling of what is the Uganda Energy Board, which essentially was the government running the entire power sector. And it evolved over a period of 5 to 6 years, up to around 2005, when they split up, essentially opened it up for the private sector. And it went from being completely owned by the government, so power generation is now separate. So the existing power generation assets are still owned by the government, but then it's been opened up to the private sector. Right now, 44% of the total installed capacity is actually private sector. And you have across the board, I mean, we have a really interesting energy mix, actually. So we've got biomass, specifically gas, feeding into the grid. We've got diesel, so local and international private sectors, so companies like Agreco from Scotland is also there. And then also equally you have local companies like a sugar factory that I mentioned earlier, Kakira, that produces also electricity to feed into the grid. And currently there's some really interesting geothermal projects that are also in development that have received funding and will be coming online between now and 2022. So it's really interesting from that sort of perspective. So legislation would be one. And second, I would say would be from the side of, from sort of consumers and how people take up tech. And how people engage with new technology and the sort of attitude to taking up new technology. Mobile money space, obviously, is one classical example of the growth of uptake of new technology. And so we see that being a really interesting parallel to look for in the energy sector as well. So that would be another thing. And then on top of that is, in our particular context, as a startup, having access to finance, being able to raise the sort of investment that's needed to do, sort of to be more ambitious rather than to step away from the classical scenario of, because we started on the classical route where we said, okay, we're going to be developing power projects, we're going to go through the traditional route of applying for this, and we got a permit, which is brilliant for a grid project, 20 megawatts, and we did that sort of traditional route as well. And then we thought, actually, maybe there's another even more exciting way for our next project in terms of bringing in more power supply to the grid. So rather than doing the classic kind of grid project, let's see what we can do on the digital side. So that would be another element to that. And in particular, focusing on that, because we looked at biomass. So we developed a grid project as well as an off-grid project that uses biomass. So in particular, agricultural waste. And often when people think of Africa and energy access, they typically just go solar. And solar is interesting, and the type of solar that people think of is typically sort of solar home systems, sort of rooftop PV, but that's super unreliable. And I just think back to this Christmas when I was at my grandmother's, and we were having a barbecue during the day, and we had the brilliant idea of just playing the music really loudly, but that used up all the electricity, which meant in the evening we had no lights. So solar, I mean, these solar home systems are interesting, but people kind of want to move away from that. People want to move to productive energy, and not only that, but actually energy that where you have a proliferation of, where you can attach the proliferation of energy generation to actual economic impact within the local community. So rather than selling equipment to people, we're in a scenario where we're actually buying the agricultural waste from the local communities, using that to generate electricity. And again, electricity that's productive, which means it can run more agro-processing and actually really start having an impact on the local economy. And why agriculture? Well, it's a country where 70% of the population rely on agriculture, and that's roughly 26% of GDP. So it does have a real impact on making things happen.
Thank you. Thank you. Have we got time for one more question? Sorry, I think you have had your hand up for quite a while. Yes, please, at the front here. Sorry to those that... We'll see if we can pick them up over drinks. I think we'll take this as the last question.
Hi, I'm Adam Woodhall from Inspiring Sustainability. I feel as though I maybe sneaked in under the cover of darkness here because I'm not an engineer, I'm afraid. But I am a communicator, and I'm interested in actually something that both Melissa and Nick alluded to, which is about how engineers need to be more than technologists. Nick said, and then Melissa said, you have to think commercial and think big. I was just thinking if there's any quick points that maybe one or two of the panelists who are engineers by training and maybe thinking and great with spreadsheets, how you're kind of...
Not an engineer,
but you're great with spreadsheets. Is that how you're kind of doing that communication, how you're going beyond what an engineer was traditionally known for and maybe only expected to be?
Yeah, Melissa, do you want to have a run at that?
Sure. So I think we are actually seeing a lot of innovation with engineers now in the North Sea, so very traditional oil and gas. There's a great example that I used in the Energy Institute article that Maersk did, Maersk Oil, where they avoided a coil tubing rig by using, a very much more coil hose and a simpler process. So I do think now, because of the low oil price in traditional oil and gas, there's a commercial constraint that was put on problems. Can we do this for X, or we're not going to do it at all? And I think for engineers, so as I said, I'm the daughter, my mom was a chemical engineer, my dad's electrical. If you can put a constraint in, then basically it actually becomes pretty easy for engineers. They just solve for a different objective function. So I think it's, can you define the problem so that you've got a constraint? Because then every engineer can work with a constraint. So if you can just say, can you do this for X? Or if you can do it for $10, what would you need to do for $10? You can only have $10. What can you do? And then an engineer can go and be as creative as possible. But it's about, I think, redefining the problem, and then they kind of just solve for it within constraints. I think engineers are amazing at that. I think we just don't define the problem. The commercial conversation and the engineering conversation, often they speak two different languages. And you can't tell an engineer make it as cheap as possible but still work. That's not. You need very clear objective functions and constraints, and then they can work better. So sometimes it's a communication of your commercial function and your engineering function to just try to speak the same language.
And from my perspective as an engineer, I think this is an incredibly exciting prospect for the engineering profession, actually. And I think it's a challenge for the academy and the rest of the professional engineering institutions to drive to much rounder, much more complete, much more wide-ranging skill set for engineers, because certainly solving this particular problem, the energy problem, and quite a few others, needs really deep knowledge of many, many disciplines beyond technology, in particular economics, social science, political science. And in some senses, you know, I think some of our difficulties moving forward fast enough in this is you know, can be explained by, you know, a lack of common language and ways to communicate clearly around these problems. You could mix it in with the, you know, the general attitude of society towards science and engineering, actually, and those as significant issues for us in tackling these very important issues that we've got ahead of us. I think I'm getting the signal that we're going to wrap up. I'd really like to thank everybody for coming, actually, and my panelists.
Awesome. Thank you very much. And just to add, actually, that was a really nice point to end on around communication, because by sheer coincidence, our next event at Science Disrupt is around communication of science. And that's on the 6th of June at Digital Science. All details are on our website. They'll be on the newsletter that'll come out on Thursday, which I've added you guys to. But I don't want to keep you any further. We've got some snacks outside. Thank you so much for coming. Lawrence is down there. I'm here. Please come and say hi if you want to chat a bit more about what we're up to. Please come say hi to the panelists. And please just give them a round of applause for coming and sharing their stories with you.